Hello student, welcome to the class of first class of computer networks. So today we will talk about IP addressing. Before that, let's wait for some 1 minute, 30 seconds to 1 minute. Okay. So then we will start with today's lecture IP addressing. So let me talk about today's lecture. What is our agenda? Our agenda is to first understand something basics about IP addressing. So there is no prerequisite. You can directly start with IP addressing here. Okay. So you will, if you want to do your revision, that also you can do with us. And after that, we will solve some questions on IP addressing. Okay, some get previous year questions, some new questions. So okay, so please verify, like you can reply that am I audible or the screen is visible properly or not. Okay, fine. Okay, thank you. So okay, so then let's start with our today's session. So first, let's talk about some basics. We will go through with some of the basic things. I know you many of you already know or this. So still, we will go through little bit on this. So IP, what is IP addresses? IP addresses is used to identify a host, that is a user in the network. Whoever we as a user, when we are using internet, we all have a when we are connected to the network, we have a unique IP address that is used to identify us in the network. Okay, so IP address is a 32-bit address which is again further divided into 4 octets. Okay, so let us visualize this. So our IP address is of 32-bit. Okay, so here is a 32-bit number which is further divided into 4 octets, each octet of 8-bit size. Okay, now this is a IP address that is unique to one user. So first, tell me how many possible values one octet can have. How many possible values each octet can have. So since there are 8 bit, each bit can have 0 or 1. So there are two possibility for each bit. So 2 into 2 into 2, 8 times. So there are 2 to the power 8 possible values a octet can have. Okay. Now, this one IP address again further divided into two parts. Okay, these 4 octets or the 32-bit number again further divided into two parts. One is called network ID, another is called host ID. So, for an example, just for an example, let's take the first octet as our network ID and all remaining 3 octet as our host ID. Okay, so in that case, tell me how many possible networks are there. So we are not talking about any classes of IP addressing currently. Okay, we are now taking it as a general. If we represent the first octet as a network ID, then how many network we can generate? How many different network ID we can generate? That is 2 to the power 8. Okay, and how many hosts we can have for each network. So when you have fixed one network, how many possible values here you can have? That is the possible number of hosts in each network. that is nothing but 2 to the power 24, 38. Okay, 3 octets are in the host ID. So this is the basic of IP addressing. Now the problem is here is that number of networks is 128. That is very less, and it is somewhere static. No? So if we can increase that network ID, in that case host ID will be less. So we have to do something dynamic here. So that's why we have the concept of classful IP addressing. So many previous year questions comes from this classful IP addressing and subnet masking. So this is a very important area in the whole networks. In the networks subject, you get at least 10 to 12 marks. So this is a very important part. So let's understand one by one. So there are total 5 classes available: A, B, C, D, and E. Okay. So how IP addresses are divided into these classes. So let us visualize this. So let's say here is your set of IP addresses. So those are 32 bit. Now the first bit of IP address can have 0. Okay. There are some IP addresses which starts with 0. Also there are some IP addresses which starts with 1. Okay. So all the IP addresses where first digit is 0, we call them as a class A IP addresses. Now, all the addresses which starts with 1, they are further divided into two category. Okay? How? So, they are again, if you zoom in here, so here all IP address starts with 1, isn't it? All starting with 1. Now the question is, what will be the second bit? Second bit here can be 0, or the second bit can be 1 again in some IP addresses. Okay. So when your second bit is 0 and first bit is 1, at that time we call it as a class B IP address. And when both are 1, it is again further divided into two classes. Now I think you got the trick how here division will happen based on the third bit. That is here all IP addresses has first bit as 1 1. Okay, all has first bit as 1 1. Now the third bit can be 0 or it can be 1. Okay, or it can be 1. Now, if it is first bit is 0, at that time we call it third bit is 0, at that time we call it as class C IP address. And here is your last division, that is when you divide your IP addresses based on fourth bit. So here 4 ones or 3 1 and 1 0. It is D and it is E. No, it is a 32-bit binary number. Okay, so each bit can be 0 or 1. Okay, okay, fine. So now let's understand class by class in detail. For class A, so for class A, now let's again draw that architecture. Okay, so you have the total whole IP address where it is divided into two parts, and the first bit of first octet, it is your first octet. Okay, here your first bit is should be 0 in class A IP addressing, that is fixed. And in class A we use our first octet as network ID, and rest all three octet are used as host ID. What is host ID? So tell me, how many network IDs are possible here? How many network ID you can have? Anyone? Please answer. Fine. So let me tell you. So since there are one bit is fixed and you have available 7-bit position, okay. So there are 7-bit positions still left. So each position can have 0 or 1 again. So there will be 2 to the power 7 possible networks. Okay. Now, in each networks, now here is a trick. So I'm coming it to later. Okay. In each network, we can have again 24-bit. Okay. In each network, when you have fixed one network, at that time, each network again have 24-bit for a host. So you have 2 to the power 24 number of hosts. It should be per network. Okay, per network. Now here, when all the network IDs are zero, that is only not the network ID, that is whole expression when all are zero, all or are one, those are used for special cases. So we will also talk about these special cases later. So for now, let us just understand this. These two IP addresses, these two network addresses also used for some special cases. So we don't use that. So number of network ID that we use is only 2 to the power 7 minus 2, which is 126. And number of host ID for that, now it is an important statement. In each network, first and last IP address reserved for special cases. Now, one thing is that when all are zeros and all are ones, that is one special case. That is okay. And again, for each network, you again fixed first and last node as your special cases for your special cases. So, in the each network, this is the possible number of IP addresses, and you have to do minus subtract 2 because these two are used for special cases. So this is the total number of possible host ID. Now, what can be the range of first octet? What can be the range of first octet? So first octet, the first bit will be 0. That is fixed. Okay, that is fixed. This is special cases. So for the first bit will be always 0, and the first IP address can be all 0, and the last IP address can be all other bits are 1 in the network ID. Okay, that is the first network ID, and it is your last network ID. Okay, so it is representing 0 and it is representing 127. Fine. So what is the range of your first octet? That is 0 to 127. And what I said, that 0 and 126, when these all are ones, okay, those are used for special cases. So we actually only use 1 to 126. Okay. So, okay. And how many total number of IP addresses are possible? Now, when we say number of IP addresses, we don't think about usable, not usable, special cases, non-special cases. We talk about all possible number of IP addresses. Okay. So since one bit is reserved, you cannot have any possibility here. And other than this bit, there are total still 27, that is 31 still bit left. So there are total 2 to the power 31 number of possible IP addresses in class A. Okay. So if it is clear, then we will go through class B and C a little bit faster. Okay. So if you have any doubt, you can say. I think you will get short notes. I'm not sure, but you can take notes along with my class. Okay, I will give time for taking notes. If you want time, you can say. Okay. Now class B. So let us go little bit faster here. Okay. Now in class B, again it is divided into 4 octet. So you have 4 octet, and again that is 8 bit each. Okay, 8 bit each. But here what is fixed? That is first 2 bit should be 1 and 0. That is fixed. 1 0 should be your first 2 bit. And here in class B, we use first 2 octet as our network ID. Network ID. And we use this as our host ID. Okay. So now tell me how many possible number of network ID we can have. How many empty bits are available? Here 2 bit are fixed. Okay, so you have 6 bit here and you have 8 bit here. So total there are 14 bits. Yeah, right. So there are 2 to the power 14 number of bits, number of networks available, and number of host per network. That is also you can count. You have 8 bit here, 8 bit here. So per network, I should write here per network. You have 2 to the power 16 minus 2 host. Okay, because for each network again you have to reserve 2 IP addresses for special uses. Now let's talk about what is the range of first octet. Okay, or we are talking about only first octet. So in the first octet, so these 2 bit are fixed, these 2 bit are fixed. All other 6 bit can be all zeros or all ones. Okay, so in this case it is 128. Okay, and here it is 191. First of all, you should always remember about like this shortcut. When there is only one in the MSB, what is the IP number? When there is two one, this should be remembered for you. Okay, in for especially for networking. So the range of first octet is 128 to 191, and number of possible IP addresses are 2 to the power 2 bit are reserved. So you have 8 bit here, 6 bit here. So 3 8s are 24, with 6 that is 30. 2 to the power 30 number of bits. Okay. Why it is 120? Because your first 2 bit are fixed. For class B, your first 2 bit should be always 1 and 0. Okay, that we have discussed in the diagram here. Okay, for class B, you can see here you have 1 and 0. So that's why when you have fixed these two, you can have all the rest of the 6 bit of first octet can have all zero, that is the minimum one, or at max you can have all ones. So if you convert this number in binary in decimal, that will be 191, and if you convert this binary number into decimal, it will have 128. Okay, so yeah, so that is about class B. Okay, now let's go to class C. Now, possibly you have guessed how the architecture of class C will be. Range of first octet. Yes, yes, I can explain. Just a minute. Okay. So, range of first octet. That means we are talking about only the first octet. That is this octet. Okay. Now, you already know that 10 will be your first 2 bit for sure. Okay. 10 will be your first 2 bit for sure. Now, the rest of 6 bit, for making the range, for find out the range, what you can do, you can find the minimum network ID and the maximum one. Okay, between them will be your range. Okay, what can be the minimum? When your first 2 bit is 10 and that is fixed, so rest of 6 bit can have all zeros, that is the minimum. Okay, and to get the maximum number, first 2 bit is obviously 10 and rest of the 6 bit will be all one to get maximum. Okay, so that's why we put all 0, we get 128, and we put all ones, that we get 191. Okay, that is the range. That means between any number, like any number between these two will have first 2 bit as 10. Will surely have first 2 bit as 10. Okay, and any number outside of this range will not have that first 2 bit as 10. Okay, now. Okay, no, here network ID will be 2 to the power 14. Here network ID will be 2 to the power 14. Why? Because in that case, in class A, you had the possibilities of all zeros. That's why we are discarding this. Okay, and you also have the possibilities of first after 10 there is all ones. Now there is no possibility here of getting all zeros. Okay, and also this possibility is not there. Okay, for network ID, because you have already fixed first bit as 1. So that's why we are not doing -2. Okay, fine. So again, let's also do for class C. Okay, it will be more clear. So in class C, again we have 4 octet. Okay, so and here you I think got the trick that first 3 will be your network ID and it will be your host ID. Only 1 octet of last one. And what is fixed here? It is fixed that your first 3 bit will be 110. Okay, this is fixed. Now tell me how many possible of network IDs are here. So total are 24 bit. This is 8 bit. So writing net host ID is I think easy now. 2 to the power 8 minus 2. Clear? And number of network ID, yes, 2 to the power 21. Okay. Range of first octet. Let us calculate that also. 110. There are still space left for 5 bit. And 110, that is the first number, and this is the last one. There is space left for 5 bit, so there can be all zeros or there can be all ones. Okay, so what is this number? This is nothing but 192. And what is this number? This is nothing but 223. Okay, okay, fine. So yeah, so range of your first octet is 192 to 223, and number of IP addresses possible, that is 2 to the power 29, because your 3 bit are fixed and you have still 29 bit left. Okay, okay, fine. Yeah, so now class D and class E, these are actually used only for special cases, special uses. Okay, reserved for like Navy, Army, their uses. So we don't have any network and like this here, but you just can calculate number of IP addresses here. Here you have first 3 bit, first 4 bit, first 3 bit as 1 and fourth bit as 0. So 4 bit are fixed. So you can have 2 to the power 28 number of possible IP addresses. Okay, and the same way in the class E, you have first 4 bit as 1111, and you have space left for 28 more bits, which are number of possibility 2 to the power 28 number of IP addresses. Okay, Okay, fine. So now let us talk about casting. That is, so when we are sending some data, how it is sent. So let's say here it is a network. You have another network. Here is some user who has IP address. It's a 10.2.1.0. And here is another user who has IP addresses. Let's say 13.12.10.10. Okay, so when this user wants to send some data to this user, it will send a packet with the message and sender id and receiver id na? Yeah, he will have sender id and it will have receiver id. So unicast means you want to send data to only one user. Okay, you want to send the data to only one user. So sender will have 10.2.1.0. Okay, this is the sender. Now he will send the data to this user, and receiver will have the IP addresses 13, 12, 10, and 10. Okay, so this is the unicast. This is the simplest one. Okay, possibly you have understood this also clearly. Now comes to broadcast. Broadcast means when you try to send a message to multiple user. Okay, send message to multiple user, to multiple user. Okay, now it is further divided into two division, that is limited broadcasting and directed broadcasting. What does limited broadcasting means? Let's say you are in a network, that is your IP address 10.2.1.0. And so what is your network IP address? This is your network. So your network will have network ID will be 10.0.0.0. Since it is a class A IP address, since it is a class A IP address, only the first octet will be your network ID. So this is your network ID. Okay, and all others are zero. Now this is called network ID. Now you have understood why we have reserved all zero bits. After when host IDs are all zero, this is used for the special case, that is we called as network ID. Okay. So when you are this user and you want to send some message to the all user, but only within your network, not the outside. Okay, you want to send something only to your network. That's why it is called limited. You are limited to your network. Okay, so if you want to send some packet to only your everyone in your network, in that case you will send some message with sender ID, your IP address 10.2.1.0, but in receiver you will put 255.255.255.255. So this is when you put this address as receiver, it will be broadcasted or it will be sent to all devices in your current network. What is your network? That is 10.0.0.0. 10 is class A, because for class A you have the range. You can easily identify, and faster way you can identify by seeing the first bit, or the faster way is to memorize the range, that is 1 to 126. Okay, this is the range of first octet. So here it is your first octet 10, which lies between this, so it is from class A. Okay, so that's why network ID is used. So what is our conclusion? That is how you can send data in within your network. What will be your sender address? What you will put in your receiver address? And what is network ID? Network ID represents the whole network. Okay, fine. So let's go to the directed broadcasting. Directed broadcasting means you don't want to send data only you within your network. You want to send data in some different network. At that time, what you will do, let's say you are in this network, okay, you want to send data in this network, okay, and this network, let's say, has IP address 13 point, like network ID is 13.000, okay, and you have the same IP address as here, okay, so you will send the data to different network, okay, so you will send the data to this network, okay. So what you will put here? Here you will put your IP address 10.2.1 10.2.10. Okay, and in the sender IP address, you don't want to send any particular person. You want to send everyone in the network. Okay, so in that case, you have to put here broadcast ID of this network, which will be 13.255.255.255. Why? Because this is a class A IP addresses. So all other bit in the host network will be 1 when you represent this broadcast ID. Okay. So for network ID, you have all zeros. For broadcast ID for a network, we'll have all ones. This is the broadcast ID. If we say clearly, that is a directed broadcast ID. Okay, sorry for this mess. Directed broadcast ID. Okay, so yeah, limited broadcast ID is always fixed. If you want to share within your network, you just put this IP address. This is always fixed. But for directed broadcasting, you have to use network ID, and after that, you make all bit as ones. So you will have your directed broadcast ID. It will change network to network. Okay, it will change network to network. Fine. Okay. So if it is fine, let us fill a table. Okay. So yeah. Now we will practice more. Okay. So that it will be more clear to you. You are given an IP address. Okay. Now we already know limited broadcast ID will be same for all. That we have already talked. Okay. So let's write it here. It will be your limited broadcast ID 255.255. Okay, and it will be same for all. Okay, so we will not talk about this. Okay, so we will talk about these two, network ID and directed broadcast ID. So first, anyone tell me what will be the network IP and directed broadcast ID for the for this IP address. Okay, for this IP address. So for that, first identify which class it belongs to, and make all the host ID as 0 for network ID, and then make all the host ID as 1 for directed broadcast ID. Right? As an answer, just write two network ID, two IP addresses, which represent network ID and network IP and directed broadcast IP. Okay. Okay, fine. Someone have answered. Okay, now I think you have answered for second one. Okay, so for the first one, your network ID will be. So someone said that it is from class A. Yes, so class A. So the first octet will be used for network ID. So it will remain as it is, and all other host bit will be 0. So odd 0 means if you convert in decimal, it will be 0. And for directed broadcast ID, it will be 1.255.255.255. Okay. So for second one is also same similar because it also belongs to the same class, that is class A. So put 10.0.0.0 and 10.255.255.255. Okay. Now I want to answer for this one. Okay. Tell me the network IP and directed broadcast ID only for this IP address. Okay. Okay. So someone has answered about directed broadcast ID. Very good. So yeah, directed broadcast ID is 130.1.255.255. Why so? Because it belongs to the class B. If you look at this octet, it belongs to the class B. So that's why you have to make all the host ID as one, and host ID is only the last two octet. Only the last two octet, okay? Not that three like class A. Okay. And in the network ID also the same way you can write 130.1.0.0. Okay. So yeah, same way we can write it here. It is also belongs to class B. So 150.0.0.0. It is a network IP, and directed broadcast ID is 150.0.255.255. Right. So for class C, same way it you can look here and you can say it belongs to class C. So just make as first 3 bit, it is first 3 octet, sorry, as it is, and the last octet will be replaced with 0, or the last octet will be replaced with 1 for broadcast ID. 1 for broadcast ID and 0 for network ID. Okay. Same way it also can be done. So 220.15.1.255. Now this will be of no use because this is a invalid IP address first of all, because each octet value can be at max 255. Okay, is it visible to you? I think no. Yeah, so this is not visible to you. I think let me write the IP address here. 123. So this is not a valid IP address, but this is valid. So that's why this is valid IP address, but not belongs to any of the classes. Like it is belongs to D and E, where we don't have all these. Okay, so fine. Okay, so answer it within like 10 seconds. I think we just have did this. Yes. So this was the easier one. You have seen. You can see the explanation from before. We have find out the number of networks possible in class C. Okay. Okay, so let me talk about like Gate 2023 test series. Possibly you know this time Geeks for Geeks also has a test series for you, which is really pocket friendly, and you have all India mock test with 22 subjective tests, 10 full mock test, and subject-wise short notes you can have. So if someone is talking about short notes, so you can get it from here. So the tests were designed by curated by the IITN. So I will recommend to check it out. If you like it, you can go for it. Okay. So this is a very good opportunity. So let us talk about subnet, and then we will go through many of the questions, okay, because most of the questions you will get from subnet, okay. So that's why more questions you will have in the subnet. You don't have many questions in only based on IP addressing. So that's why let's also cover the subnet, okay. First, uh, so what is the subnet? Subnet is that, let's say you have a college and you for your college you have bought a network ID of class C. That means you can have 255, actually 254 number of hosts connected to your, like, at that many number of students can connect to your network, okay. But let's say there are two or three department, and you want to have different subnet or different network for all three departments, okay. It will increase the security also, okay. So that's why what we will do, we will apply subnetting. Subnetting, what will happen, the network already we have, that will be further divided into more two and three networks, okay. So that will be further divided into two or three networks, how many we want, okay, we can divide it, okay. So the subnet, the network is divided into more smaller networks. Each smaller network is known as subnet, okay. For subnet mask, we will see subnet mask in our example, okay. So first go to the examples, we will understand more in the example. Let's say we are given a network, okay, 200.120, okay, this is a network ID, okay, and this is belongs to class C, okay. Still these are not visible, okay, I will write it later here, okay. Some text are not visible, not to worry, okay, I will write it, okay, fine. This is from class C. So say this is your class C IP at class C IP address, that is network ID 120, okay. Now you are asked to divide it into two subnets, okay. Now here this network can have 254, let's say 256 IP addresses. We are talking about IP addresses. We will go to usable and reusable, like usable host later, okay. So there are total 256 IP addresses, and we want to divide it like 128 here and 128 here, okay. So let's write down the last octet, okay, last octet, okay. So the same trick we will use for dividing it into subnets. The trick we have used for classful IP addressing. That is, we will fix again another bit for each subnet. Let's say for subnet 1, we say in the host ID, okay. Look, in the host ID, the last octet belongs to the host ID, okay. In the host ID, if your first bit is 0, then this belongs to the first subnet, and if your first bit is 1, okay, other can be anything, okay. If your first bit is 1, we are saying it belongs to the second subnet. So let's say you have one subnet where the possible range are, first bit will be obviously 0 and all other can be 1 at maximum, okay. This is the minimum and this is the maximum. Again, this is the minimum one for subnet 2, okay, and this is the maximum one for subnet 2, for subnet 2. Now if you consider the whole network, what is the network ID? Not IP, I should not say IP, that is network ID, okay. That is 200.1.2.0. It was the total network, whole network ID. And what was the broadcast ID? That was 200.1.2.255. We have solved this type of question just before, okay. Now if you see about subnet 1, what will be the network IP? A network ID and subnet to network ID. Again, it should not be IP, it should be ID. ID. Okay. So for subnet 1, your network ID is nothing but the minimum one. When you put all the bits are as 0. Okay. So for the subnet 1, your network ID is 200.1.2.0. Okay. Otherwise, and if for subnet 2, your network ID is 1, 2, and the first bit will be always 1 and all others are 0 for your network ID in the subnet 2. So it will be 128. Okay. This is about your subnet 1 and subnet 2 network ID. Okay, when first bit is fixed and all other host ID. So we put zeros and 1 in the host ID. Okay, but the first bit is no more host ID. When you do subnetting, the first bit no more remains as host ID. It becomes a subnet ID. Subnet ID you can say or subnet bit. It is used as subnet bit. It is used as subnet bit. Okay, so that's why you just make all host bit as 0 and all host bit as 1. Now this is not visible, so this is nothing but subnet 1 broadcast ID and it is subnet 2 broadcast ID. What will be that? That will be the maximum one. When for subnet 1, you can see this all bit will be 1, but not the first bit, okay? So it will not be 255. It will be 127, 200.1.2.127 and 200.1.2.255. Okay, sorry, 255. Okay, so when all are 1, this is for subnet 2, and you are also asked to find out subnet mask. What is subnet mask? In subnet mask we put each digit as 1 where you have network ID, it belongs to network ID, or it belongs to subnet ID. Those all are considered as 1, and all the bit belongs to host ID considered as 0. Okay, so let's say for these 3 octet, first 3 octet, we know surely first 3 octet are network ID. So in no doubt, all bit we will put 1. So all the first 3 octet will be 255, 255, okay, 255. Now, what will be the last octet? The last octet, the first bit now is subnet ID. So the first bit will be 1. Okay, first bit will be 1, but all other left 7 bits now your host ID. So all of them will become 0. Okay, 0. So your IP, your subnet mask becomes, this is as 128. So this is your subnet mask. This is your subnet mask. Okay, now we can look at the definition once. Okay, what is subnet mask? It is a 32-bit address where network id and subnet id network id and subnet id replaces with ones and host id replaces with 0. Okay, so I think it is clear to all. If you have any doubt you can tell me. Okay, otherwise we are going to the numericals. Okay, fine. So try this. Okay. uh, you have how many? 1 minute. Okay, fine. 2 minutes for this question, but I will also say a trick using which you can solve it in 10 seconds also. Subnet mask. Okay, you guys please solve this. Just read out the take the screenshot of the question. Okay, till that time, let me also explain this once more. Subnet mask. The subnet mask, what we did in the network ID here. Now you know this is a class C IP address. So in the class C, first three octets are belongs to network ID. Okay, first three octet belongs to network ID. So in the first three octet, you put all bit as ones. You put all bit as ones. So when you put all bit as ones, so first three octet becomes 255, 255, and 255. Okay, when where why you put all ones? Because those all belongs to network ID. So you have 255 dot 255 dot 255. Now in the third octet, before it was all host ID, but after doing subnet, after performing subnet, your first bit is no more host ID, host bit. Okay, your first bit now became as a subnet bit. That's why the first bit only you will put as 1 and all other are again host ID. So you can keep it as 0. So your this last octet becomes 128. Okay. So any answer of these questions? Of the question, please. Okay. Someone is saying A, 10 digit. Okay. Okay. Fine. So let me continue. So what they are saying, the organization has a class B network. Okay, class B network means, let me visualize here. So that means first two octets are your network ID. Okay, fine. And this should be my host ID. Okay, okay, fine. This is my host, this is my network. Okay, then they are saying that you use you just a minute, just a minute. Okay, so you wish to form 64 departments, subnets for 64 departments. Okay, so you want number of subnets to be 64. That means you want to divide it into 64 subnets. That so using for dividing it to two subnet, we need one bit. So using one bit, we can divide it into two subnets. So using 2 bit, you can divide it into 4 subnets. Using 3 bit, 8 subnet, 4 bit, 16 subnet. That's why 5 bit, 32, and for using 6 bit, you can divide the whole network into 64 departments, 64 subnets. So you need how many? You need here 6 bit required, okay, to make 64 departments, 64 subnets. Okay, so from where you will take this 6 bit? From network ID? No, we take this 6 bit from host ID. So I will ask host ID to give me 6 bit. Okay, So still host ID here they have 2 bit and here also have 8 bit. Okay. Now when you calculate the subnet mask, you will put all ones here. Okay, and all ones in these 6 subnets. So your subnet mask will be all ones in the first 2 octet. Okay, one more I think, yeah, and 6 ones in the third octet with 2 zeros, and last octet will be obviously 0. Okay, now what is this subnet? Now to convert it, this is easy. 255. Now for this you can memorize, okay, the IP addresses conversion. But another way is to do this. Okay, so another way to do this is that, if all bit were ones, at that time you would have written 255, but last two bit are not one, so this will be subtracted. So if last two bit 1, that means it is 3, so 3 will be subtracted, so that is 252. That is the easier process for conversion. Okay, this is nothing to do with networking. Now, okay, someone is asking how 2 bit and 6 bit are separate. Okay, this is separated because of we have to build 64 subnets. So to build 64 subnets, we need log of 64 bits. Okay, we need log of 64 bits, which is 6. Now from where you will take this 6 bit? You can take 6 bit from host ID, only host ID, not from the network ID. So this 6 bit you have taken from this host part, and you still have now total octet size were 8 bit, and you have allocated 6 bit to the subnet ID. So you have 2 bit left here. 2 and 8 total 10 bit are left for your host. 10 bit left for your host, 6 bit for your subnet, and 16 bit for your network. Okay, fine. Okay, so D is the correct answer. Fine. So, okay. Let me first explain the question. Suppose a computer A and B have IP addresses this and this. Okay, fine, respectively. They both uses the same network net mask N. Okay, so they both have same network marks. Okay, that is network mark. Okay, fine. What is the value of n should not be used if A and B should belong to the network. Okay, now you want A and B should belong to the same network. Now you have to say which of this option, if you use as the subnet mask, A and B both will have same network. Now let me say here one thing. Any user can get its network ID using the formula subnet mask perform AND operation with its IP address. Okay, if a computer A, let's say it has this IP address, if it performs AND operation this with N, it will get A's, it will give, as a result, it will give A's network ID. The same way, B also can get B's network ID. Now you have to choose a N from this list which gives same network ID. Okay, so tell me the answer. Now here also there can be a short trick using which you can identify a little bit faster, okay, than the normal process. So first you give it a try. You have 2 minutes, okay, 2 minutes to solve this. Just a minute. Oh, yes. So, so let me explain how you can solve this. So, if this was your net mask, let us consider this was your net mask. This net mask is used for A and for B also. Then let's say A's IP address, you know, 10.105.1.113. B's IP, sorry, not B's IP. So we will do perform AND operation between subnet mask and IP address. So A's IP I have, let's say broadcast ID that we have assumed as option A, which is 255.255.255.0. Now perform AND. In the same way, B also have IP, okay, which is 10.105.1.1 dot 91. Okay, so here B in also network max for B also the same, 255, 255, 255.0. Now what is the network ID? A's network ID. A's network ID is perform the AND operation. Now when you perform AND 10 with 255, now think it as binary, okay? Do it directly. So all are ones. Now here some are ones, some are zeros. So when you do AND operation, 0 with 1 will remain 0, 1 with 1 will remain 1. So just put it directly as 105, 1, and at last it is 0 because AND operation with 0 will result 0. The same way, B's network ID, okay, equals to 10, 105, sorry, 105.1.0. Okay, is it clear? Just a minute, I think there is some issue I'm facing. Just a minute. Kindly please reply, is my voice and screen is properly visible? Is it visible? And am I audible? Okay, okay. Sorry for this delay. Okay, fine. Yeah. Okay, fine. Thank you. So, okay. So somehow we calculate network ID. Okay. Now, network ID we have calculated using this formula, using subnet mask, performing and with IP address. Okay, so why subnet mask is important? In the subnet mask, you put on once only there where you have network ID and the host and the subnet ID. Okay, that's why when you perform OR na, at that time the bit will be left will be only of your network ID. Okay, only this bit will be active, which belongs to the network ID or subnet ID, and it is active in your actual network ID. So that's why performing AND, here we are doing nothing, just performing AND operation, digital logic AND operation. If you take each bit, okay, let me show it for one octet. Okay, I think it will be more clear. So it is 0 0 0 0 0. For 8 it is 1 4 2 0. Okay, this is the binary of first octet, that is 10, and for 255 all are 1. Okay, if you perform AND operation, it will be all 0. Okay, fine. Okay, so what is this number? This is same as this na. That's why we have written it directly. So performing AND, it will be 10. It will be 105, it will be 1, it will be 0. So you can see both have same network ID. Okay, fine. So also let me try for B option. Okay, so every time you don't have to do this AND operation. You now, when you got that trick, you can find it directly. Okay, like do AND operation AIP with B with this as N. Okay, now 255 you will have 10, 255 with 105 and 1. So these three you will get same in both time in network IP. Okay, so this can make the difference. Okay, so here you have 128. That means the leftmost bit. So this is the octet looks like. Okay, this is how the octet looks like. Only the leftmost bit is active. Okay, here you can see one, it is lesser than 128. That means leftmost bit is not active. Here also it is lesser than 128, so leftmost bit is not active. So if you perform AND operation of this IP address with this as N, you will have same result. You will have result as 10.105.1.0, because the bit which is active here, that is 1, at that time it has 0, and when it all has 0, at that time it can have 1 or 0, anything. Okay, so you can do this AND operation directly, you don't have to do all these things. Okay, now here again, if you consider this as your N. Okay, so here last two bit are active, leftmost two bit are active, that is 1 1 0 0 0 0 0 0 0. This is your last octet. Okay, so when you perform AND operation of this octet with 113 and 91. Okay, 113 and 91. Now look it like that, like consider it like this. They both don't have 128. Okay, that means both will have in the result of network ID. Okay, the result of network ID, last octet will have 0 in the first bit in both of the cases. Okay, because when you perform AND operation, okay, that will result 0 in the second bit. In the second bit of last octet, that is 64. Now your subnet mask has 1. Consider this is greater than 64. That means this also has 64, because 64 is the first bit, the first largest number. Na? and 91 also has 64. Otherwise, if you are not comfortable with that much complicated thing, you can go with basic. You can do and operation. It will consume more time. Okay. So yeah, so it also has 64. So in the result, you will have one here in the network ID, and remaining or will be zero because subnet mask itself has zero. Okay, subnet mask itself has zero. So that's why these in all three cases we have the network A and B belongs to the same network. A and B belongs to the same network. Okay, and we are asked to find which should not be used. So D should not be used. Okay, D should not be used as our subnet mask because you can perform again with D the same way. Okay, if you perform it with D, its last bit is 224, last octet is 224, which will be 110.0.0.0.0.0, and in the two IP addresses given there you have last two octet as 113 and 91. Okay, 113 and 91. Okay, in both of the cases you will not, like if you perform and this with this and this with this, you will have two different results. Okay, fine. So okay, now let's solve this one. This is the easier one. I think you can do it. Just do it. You are given a class B network with internet address, that is the network address. Internet, okay, sorry, not internet address. Internet has a subnet mask. Subnet mask is given. What is the number of hosts possible? Maximum number of hosts possible. Okay. So in the 248, okay, that is representation is there is four ones and four zeros. Okay, I think so. 254 up to 48. Okay, fine. And here you have all are zeros. Here all are zeros. I think no. Here one more will be on. 248. It is 7. 248 can be written as 255 minus 7. So that means last 3 bit will be available. Okay. Last 3 bit. That is 11111000. Okay. Now you know the bit here zeros represents host ID. Host ID. Okay. So now you can say how many hosts are possible per subnet. You have 11 bit. So 2 to the power 11 minus 2 to the power 11 minus 2, which is 2046. Number of hosts per subnet. That means you take the host ID. You have to identify for that which are host ID, which are subnet ID, which are network ID. That's where you have to be very much clear. What is subnet ID? Now here you cannot identify subnet ID, but when you are given a subnet mask, you can identify host bits. Which are the host bits? Host bits are which are zeros. Those represents the host bit. Here you can see like 255, 255, all are ones. So they may belong to network ID or subnet ID. We cannot be sure. After that, in 248, we have 5 bits at 1. So those 5 bits can be again network ID or host ID, anything. We will not comment about it. But there are 3 bits which are 0. So since they are a 0 bit, we are sure that those are host ID, and the last octet is also represents host ID. So total there are 11 host ID, number of possible host per subnet, that is 2 to the power 11 minus 2. Why we have to minus 2? Because that same logic, network ID and broadcast ID, for each subnet you will have network and broadcast ID. Okay, now is it clear? 0 means zeros in subnet mask. Okay, zeros in subnet mask, you are sure that represents host ID. Once in subnet mask, you are sure that it may represent network ID. It is network ID or subnet ID. Okay. Now they are asking about number of hosts. Okay, number of hosts. That means you have to look how many host bit you have. Now look at go to the basic. When you are doing like classful IP addressing, okay, classful IP addressing. In the class A, okay, in the class A, what you are doing? You are taking this as network ID, okay, and this or one host ID. This or one host ID, okay. That's why you are what you are doing. You are considering 2 to the power 24, because there are 24 host bits, so number of hosts where 2 to the power 24 minus 2. The same way here host IDs are only this much bit. So here it is only these 11 bits are host ID. Okay, so what is the number of hosts possible? That is 2 to the power 11 minus 2. Okay, fine. Okay, so let's go to the next question. Okay, so okay, we will try to solve more of your doubts with the questions. Okay, let's try this. Okay, let's try this. So what it is saying, the address of a class B host has to be split into subnet with 6-bit number. Okay, now understand, you are given a class B IP address, that is class B network. Class B network means you have 4 octet and first 2 octet belongs to the network ID. Okay, fine. Last two octet belongs to the host ID. Okay, fine. Now this has to be split into subnets with 6 bits number. Fine, 6 bits number. That means you will have to take 6 bit for your network, for your subnet ID. From where it will take, you will take this from host ID. We just said this. So from host ID, now this was your whole host ID. Okay, from here you will take 6 bit number. Okay, 6 bit number for your subnet ID. Okay, so how many you will have? 2 to the power 6 minus 2. Okay, and how many hosts in each subnet you are having? Each subnet, how many bits are left? Just count it. You have used 6 bit for subnet, so you have left with 2 bit. You have left with 8 bit. So total there are 10 bit. Total there are 10 bit. So 2 to the power 10 minus 2. Okay, 2 to the power 6 minus 2, that is the number of subnets, and 2 to the power 10 minus 2, that is the number of hosts per subnet, because this represents the host ID, and 6 bit that was given in the question, that is used for your subnet ID. Okay, so number of subnets are nothing but 62. Yeah, and it is 1022. Fine. So there are 62 subnets and 1022 hosts. Okay. Now let's come to the next question. So you have two computers C1 and C2 that are configured as C1 IP address is given to you and C1's netmask is given to you. Okay. C2 has IP address that is given to you for C2. Okay, and netmask also given to you. Now you have to find which are the following is true, that is C1 and C2 both assume they are on the same network. Now and say like they both assume they are on a different network. You can understand these options. Okay, fine. So first let me, so for that you have to understand first what C1 thinks that C2's network. Okay, what C1 thinks about C2's network ID. Okay, fine. For that, what you can do, you can perform and between C1's subnet mask with C2's, sorry, C2's IP address. Now, C1 has its own subnet mask. It can perform the AND operation with C2's IP address. Now, when you perform subnet AND operation between subnet mask and IP address, you got network ID. Okay, that is clear to all. You got network ID when you perform AND operation between subnet mask and IP address. So the network ID you will get, that is what C1 thinks C2, here C2 considers, C1 considers C2 is in this network. Okay, this network. Fine. Now the same way you can do it for C2. C2 thinks about what C2 thinks about C1's network ID. Okay, for that you can perform AND operation between two. You have to get network ID. Na? You have to check if both are in same network or not. What C1 thinks C2's network ID. Okay, and here compare with C1's network ID. Okay, here also perform AND between C2's subnet mask with C1's IP, and again the same way what C2 thinks about C1 and compare. Okay, so let me do it for one. Okay, so mm, what is C1's IP? So we have to perform AND operation between and the person between C1 subnet mask and C2's IP. Okay, C1 subnet mask, that is 255.255.128.0. Okay, 255, 255, 128 and 0. Okay, now C1's IP I have written, sorry, C1 subnet mask I have written, and I need C2's IP. Okay, C2's IP is 203.197, 75, 201, 203, 203, 197. This is very difficult to go to the previous page and write it again. Okay, subnet 197, 75, 201. Okay, fine. 75, 201. Okay, perform and what you will get, you will get C1's assumption on C2's network ID. Let's see what C1 thinks. C1 thinks that, okay, the perform AND. Okay, now I think it is clear. For the AND operation, 250, here it is, you have 255, that is all ones. Here you can have ones or zeros, anything. When you perform AND operation, you will get 203, the same what you have here. Okay, now AND operation 255 and 197, 197. Here, the AND operation between these two numbers. Now look, 128, that means only there is one and all are zeros. Okay, here the first bit is obviously 0 because it is not 120, it is lesser than 128, and all other bit anything it can be. Now when you perform AND 1 with 0, you have 0. Okay, and these all will be also 0 because these are 0. In the AND operation, if one bit is 0, then your result is 0. Okay, so, and here also, since all bits are 0, you have as a result all bits are 0. Okay, this is the C2's network ID that C1 thinks. Okay, now what is C2's actual network ID? Actual network ID that you can get with performing AND of the networks and IP address of C2. That is, C2 knows where C2, what is the C2's network ID. So that's why you can perform AND between these two. Now I can do this AND here directly. That will be 203 because 255 and 203, 255 and 197, and will be 197, and between 192 and 75. Okay, now you can again do it manually, or you can look it like this. Here you have 128, 128 bit. Okay, and here you don't have, so this will have 0 here, but in the 64 bit. Okay, okay, fine, let me do it here. Okay, this is as 192 and 75 is can be here, and some bits are later. So 0 and 1 end with 0, but 1 and 1 end will be 1. So 64 and all will be 0. Okay, and the last octet is also 0. So this is the actual um, network ID of C2. Now the same way, what will be the actual network ID of C1? C1's network ID will be 203.197. Dot. Now you are performing AND of C1 IP address with C1's subnet mask. Okay. So you have 2 here, you have 128 here. If you perform AND operation, so only the leftmost bit is set here and leftmost bit is not set here. So the result will be 0 of AND operation. And here is you have again 0. That is C1's actual network ID. Now, now look at this statement, okay? C1 thinks C2 is in this IP address, okay? So, and C1 actually is in this IP, this network ID, okay? So C1 thinks, C1 assumes C2 is on the same network, okay? This can be the option or this also can be the option, okay? Okay, so C1 thinks C2 is in this IP at this network, and C1 itself present in this network. So C1 thinks that C2 is also present in my network. Okay, that's why C and D can be right answer. Now we have to do vice versa operation. That is C2 subnet ID with C1's IP address. Okay, so let me do it here directly. That is perform and between C2 subnet mask with C1's IP address. Okay, that is what C2 assumes. Okay, let me write answer here: 203.197. Now here you have 192 and here you have 2. So here you have only first 2 bit as set, and in 2 you have only this bit as set. So perform AND operation, you will get 0, 0, 0. Now look at this. C2 is present in this network and C2 thinks C1 is present in this network, which are different, which are different. So C2 assumes C1 is on a different network because C2 present in this network that we have got by performing AND between C2's IP address and C2's net mask. Okay, and what C2 thinks about C1, for that we have performed an operation between C2 using, we are using C2 subnet mask for finding network ID of C1. Okay, so for finding C1's network ID we are using C2 subnet mask. That's how we can achieve how C2 thinks about C1. Right, so C is the correct answer, D is not. Fine. Okay. Okay. The subnet mask for a particular network is given. Okay, this is interesting one. Okay, you may see something different here. Now let's write it. Okay, 1 1 1 1 1 1 1 dot. So this is how the subnet mask look like. Okay, now which of the following addresses could belong to this network? Okay, so now the question is same. You have to find the network ID and you have to find which pair of IP address belongs to the same network, belongs to this network. Okay, so that means when you perform AND operation between subnet ID, this given subnet ID with the IP address, the result you will get, that will be network ID, and that network ID should be same for this one also and for this one also. Okay, so if you perform AND of this IP address with this. Okay, what you will get? Let's write it as A. What will be your network IDs? Now the first octet is all ones, so you can write it directly 172.57. Now if for 88 you have to calculate, and last one will be 0 because all are zeros here. Okay. Now what will be the third one? For that perform AND operation here, and okay, and okay, 56. Okay, now here you have 56, and there can be something here, and last bit is obviously 0 because all are 0. We are performing AND between this subnet mask with these IP addresses. Now, if you look, you don't even have to calculate this because after all, you want to compare if these two networks are same or not, same or different. Now it is already different here. Here you have 57, here you have 56. So why you will compute this? Okay. So you can directly say this is not your answer. Okay. So because they are asking could belong to this network because these two cannot be. Okay. Now, let's consider for this one. Okay, for B option, the end perform will be 35. Now we have to calculate for this, and last one will be 0 and 10. The 35 dot there will be something, and the last one will be again 0. Okay, fine. So let me now calculate. For here you have 28, here you have 29. Now actually here you also don't have to calculate. You can directly check. Since it is a even number, since it is a even number, in the binary representation of 28, the rightmost, the LSB, will be 0. Anything can be present before. The rightmost will be obviously 0. Here, the rightmost will be obviously 1 because this is an odd number. So this concept belongs to digital logic. Okay. So since rightmost bit is 1, since that's why it is an odd number, rightmost bit is 0, so it is an even number. So when you perform the AND operation, na, here you see you have 1. So when you perform AND operation this with this, you will have result 0 as the rightmost bit. And when you perform AND operation between this and this, the in the third octet, rightmost bit will be 1. So these two will be different. Okay. If this is difficult to understand, again you can perform AND operation between these and these two octets. Okay. So you will get also that to be different. Okay. Here also you can directly see this is different both in both of the cases, 203 and 234. Okay, so that's why you can directly say C is not your answer. A, B, C are discarded. So obviously D will be your answer, but let's also verify. For D, you have 128.8 dot something dot 43 and 128.8.161.55, sorry, not 161. We will perform an operation. Now consider in 129 what you have. Oh, you have 128 plus 1. That means this bit is active and this bit is active. So when you perform AND operation, all middle bits are 0 in this. So in the result, we will also have all bits are 0. The first bit is 0 here. So you in the result also you will have 0 in this first bit. Only the last bit is where this is also 1 and here you have also 1. So this is 1. Hmm. So both are odd. So both the MSB, that is 1. So also you have to verify for these all bits so that these all bit doesn't interact. Okay, doesn't intersect. Okay. So 161. For 161, how you can divide it? You can divide it like 128 plus 32. That is 160 plus 1. That means this bit is active, this bit is active, and this bit is active. So when you perform AND operation, only this bit will remain active because all other cases it is 0. And when these are 1, at that time these are zeros. That is why in 161 those are zeros. So here also you will have only 1. Now look at this network ID. What is this? These are network ID. How you can be sure that this is network ID? Because you have performed the AND operation between subnet mask and IP address. Okay. So D is the correct answer. Fine. So that's how you can solve it in less time also. Now we will talk about variable length subnet masking, which is a easier concept if you have understood subnet masking very clearly. Yeah, time consuming. That's why also I was at the time of explaining I was also saying short tricks like just looking at the binary number, just visualizing how you can discard options. Okay. So variable length subnet masking. Now you are given an IP address 200.120 and you have to divide it into three subnets. Each will have 128, 64 and 64 IP addresses. Now you could divide it into four subnets. You could divide it into two subnets using one bit. Okay, you will require 2 bit to divide it into four subnets. But here you are asked to divide it into three subnets. So again you have this 200.1.2.0. You have to divide it into three subnet. Let's say subnet 1, it is subnet 1, subnet 2 and subnet 3. Subnet 2 is here, subnet 3 is here. Now look at this. So you have 200.1.2 dot all as zeros. I'm just writing it this as last octet. First identify this belongs to class C. Okay, this belongs to class C. That's why this is the only host ID. Okay, this represents the host bits. Okay, so that's why we have written just a host bit because we will take subnet bit from host bit. That is the most important thing. We will borrow subnet bit from host bit. For S3 also you will have. Fine. So now, what you can do to divide it into three subnets, you could divide it into four subnet by like you saying that first two bit here will be 00, 01, 10, like 10 and 11. But what will be the problem? You are dividing it into four, but you want it to be three. So that's why merge these two. Don't reserve 2 bit for subnet, just reserve 1 bit. Okay, just say if the first bit is 0, only the first bit you consider as your subnet bit. If the first bit is 0, at that time it belongs to subnet 1. Now if first bit is not 0, then that means first bit is 1, and then look at the second bit. If second bit is 0, then it is subnet 2. If second bit is 1, then it is subnet 3. Okay. So now if you look at how many like IP addresses each subnet has, since you have reserved only 1 bit as subnet mask, how many host ID, how many host bit you are left with? 7. 7 bit. That is nothing but 128. Here you are left with 6 bit, which is nothing but 2 to the power 6, that is 64 host. 64 IP addresses. Here also you have 64 IP addresses. Now in the same way you can find out what will be the network ID, what will be the uh, broadcast ID for each subnet. Okay, so let me write it here. Okay, for subnet 1, okay, total number of users, total 128 available IP addresses are there, but you have to do minus 2, so 126. How many network ID you have, and how many not, that is the what is the network ID, that is nothing but for the subnet 1 it is 200 120 200 120. Why 0? Because first bit is fixed 0, and all the 7 bits you have put it as 0. Now broadcast ID 200.1.2. The first bit is 0. Now all other you have to put 1. So what will be that number? That will be 127. Okay, fine. Now what will be the subnet mask? For subnet mask, these first three octet are network ID. Okay, so just put ones in all first three octet. We have discussed these rules. Okay, and in the subnet bit, which is the subnet bit, that is the first bit of the last octet. Okay, there you have to put one only, and all other 7 bits were first bits, so you put 0 there, so you have 128. What is the number of bit in host id? The host id number of bits are 7. Subnet id there is 1 bit, and in the network id you have all 3 octet, that is 24 bit. Okay, the same way, let me fill this quickly. 62. What is the network ID? 200.1.2.128. Why 128? Because look at here, this bit is fixed. To find network ID, you have to put all zeros here. And to find the broadcast ID, you have to put all ones here. Okay? So broadcast ID is 200.1.2.191. The subnet mask 255.255.255 dot here in the subnet 2 you have taken 2 bit for subnet ID. So first 2 bit, if you put 1 in first 2 bit, the binary number will be 192. So host ID you have 6 bit left, you have taken 2 number for subnet ID, and you have taken 24 for network ID, it was given. So yeah, it's the same way you can put subnet 3, just a change will be in the network ID, which will be 200.1.2.192, and otherwise all will be same. Okay. And the broadcast ID will be 200.1.2.254. Sorry, 255. Okay, fine. So if you talk about the whole network, so yeah, whole network ID, this was already given in the question. That is 200.1.2.0 and 200.1.2.255. Okay. And number of bits in the host ID, that is 8. Total number of users, if you consider the whole network without doing any subnetting, then total number of hosts you have, that is 254. That is equals to 2 to the power 8 minus 2, because you have 8 bits for sub host ID. So there are 2 to the power 8 possible addresses. Using these two, from these two you reserve 2 for special purposes. So you have 254 total number of users. Okay, fine. This is the last question. Right, you have an organization which has a class C IP address and you want to have three subnetworks, okay? One with 110 hosts, two with 60 hosts each. Which of the following possible set of subnet addresses and subnet masks? Okay, possible set of subnet address, that is, so these one are subnet address and this is subnet mask. Actually, it is given subnet address and yeah, it was given reverse direction. So subnet mask and subnet address. Okay, so do it now. Also, let me tell you some short tricks. Okay, first let me tell you how you can divide it. Like you total. This is a class C IP address. Okay, that's mean you have 8 bit for 8 bit. You have 8 bit for a host. Okay, and you can have possibly 254 number of hosts. Okay, now you want to divide them into 110 and 60, which is kind of same as just we have divided. Okay, so you have total 200, 200, 200 dot 0, which will be again divided into three subnet, S1, S2, S3. Now we will just care about last 8 number, no? Last octet. Okay, that is last 8 bit. Waiting. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now look at the first one. Okay. Now it is given that subnet 1 will have subnet mask as 192. That means the first 2 bit is they are using for the the first 2 bit they are using for the subnet mask. That means how many bits are left for host ID? Only 6 bit. Total there was 8 bit. 2 bit you are using. They are using 2 bit for what? For okay. 2 bit used for subnetting, which implies 6 bit left for host, which implies there are maximum 62 possible hosts. There are maximum 62 possible hosts, but in the first network you want at least 110 hosts. So directly you discard this. This may long a very big question to you, but it will not take time if you smartly discard all the options. So A is discarded, B is discarded because B also have 192 here. Okay. Now you are clear that since first one will have at least 110, then first this octet should be 120, should be, must be. Okay. Now this can have 192, that is maximum 62 host. So 60 host you want, so it's okay. You can have 192 here, so 128 here is okay, 192 here is okay, 192 here is okay. So these two now you are left with. Now don't just go for solving, look at where is the difference. Now they are saying that subnet address are same for all three subnet. So directly here you can say it cannot be possible. But also if you do mathematically, now if this was your subnet mask, you can what you can do, you are using 2 bit for subnet. Okay, you are using 2 bit for subnetting s2. Okay, fine. 2 bit you have used. Now these 2 bit are reserved for subnet. Okay, fine. Now these 2 bit may have 1, 0, and all are 0. It is okay. Now you can have 128 as your network address. Fine. Now in that case, here if you take 10 as your subnet ID here you have to take 0. You must take 0 here. Huh? Okay, because you have to take like only one bit as subnet bit here, so subnet bit, so you cannot have one here because one is used here. If you have now 0 here, even if you put all zeros, that is for your network, you cannot have 128. Can 128 cannot be your network ID. Okay, that's why the last one is correct, because here what you are doing, you are putting 1 here. Okay, you are having 128 in the last octet. In the S2 you are putting 0 here, but first 2 bit can be 00 or 01 in the S2 and S3. So when all are 0, that is nothing but the case of this, and when these are 1, this is 64, which is this, and here you have. Okay, fine. So thank you, it was really a good session. Okay, so you can find the contest link. Okay, you have one contest that is available, that link is available in the description. You just attend that and let me know your feedback. Okay, so thank you all, best of luck for your exam, it is not very far. Okay, best of luck. So possibly we will meet again in the next class, so still, so best of luck. Thank you. Bye.